Okay, so continuing where we left off at. So the problems are going to gradually get harder. Make sense? We're baby steps. The ones we're going to do now we're somewhat consider beginning, and we're going to keep going from here. Now, what I want to reiterate is I do not want you guys to forget rules that you already know. Okay. When you have anything outside of parentheses, what property do we use to put them inside the parentheses? Anybody? Everybody? I heard the D word. Distribution. Okay. One of the feedback things that I got was that I should go back to using the cards to call on people. Yeah. So one. I should go back to using my cards to call on y'all since y'all when y'all don't want to say things out loud. All right. So I got the cards ready. All right. So we're gonna first start off with what we already know, which is the distribution property. Bro. So I'm going to distribute this into each term. Does that make sense? So I'm going to end up with 3x squared times xy squared plus 2y squared times xy squared. That's just regular. We haven't used any of the exponent rules because we already know when there's something outside of parentheses, we're going to do what? Distribute. Remember, if you can't see, you can always open the Zoom so that it's in front of you and you can full screen it from there. All right. So now we're going to apply our exponent rules. Exponent rules are when the bases are the same, you can use the product, quotient, you can use all these rules to combine. Does that make sense? All right. So starting with our first term, and we're going to talk about terms. Remember, terms are separated by addition and subtraction. So this is our first term, and this is our second term. Does that make sense? Okay. You only can combine terms if they have the exact same variables. If their variables are not exactly the same, you cannot combine their terms. All right. So now let's focus on the first term. So looking at our first term, does 3 have a friend to combine with? No. But we have x squared and we have x to the 1. Remember the power of 1? If there's nothing there, there's always a 1. So how many x's do I have? 3. I have x to the 3. Okay. And then does y have a friend? No. So it's just y squared. Now we're on to our second term, doing the same thing again. 2 has nobody, so it's just going to be 2. Y, I have y squared and y squared. How many y's do I have? 4. Y to the 4. And then x has no friend. These variables have to be the exact same, meaning the exact same power on them. Are these exactly the same? So guess what? I can't go any further. That is my answer. If the variables are not exactly the same, meaning the same letter, same power, I can't combine terms. All right, everybody, what's the answer to 6? What's the answer to 6? I need everybody to answer to 6. Why? Anything to the power of 0, doesn't matter how many factors, how large it is, the answer is going to automatically be 1, no matter what. No matter what, it's going to be 1. So don't fall for it. You can distribute it if you like, but what is it still going to be? 1. All right. Got it? Okay. I'm going to say that means that we all got it based on that sound. All right. Let's keep going. So 7, we have 4 to the y plus 2 and 4 to the 6. Our bases are the same. So that means we can use our exponent rules, right? Because the bases are the same. Which rule am I applying here? Product rule. Product rule. Product rule means that if my bases are the same, which they are, all I'm doing is adding their powers. So we have y plus 2 plus 6, which means our final answer is what? Perfect. 2 plus 6. Oh, it's a funny. Oh, my 8? Yeah, it's an 8. It got a little funky. All right, on 8, we're about to use like six rules. But we have to just use them all. We're gonna use all the rules that exist. Okay? All right, out the gate. When you are working problems that are large, work them from left to right, top to bottom. Does that make sense? Left to right, top to bottom. That's the order, just so that you can stay organized and consistent. So we're going to start here with what's most to the left. All right. So we're starting with this guy. What is the first property rule we're going to use? Power of a product. Power of a product because, well, power of quotient, actually. Yeah. It's like, wait, product is next. Power of quotient. I'm going to distribute the power of 2, the power of 2. Make sense? So you're going to become a to the 8 over b to the 6. Oh, he slides in his chair. All right. Now we're going to do what? But now we can use power product, right? So now we're going to do power product. So we're going to distribute along with power of 1, which leaves us with a to the 6 and b to the 3. So we did power of quotient, power of 1, power of product. Yes? All right, that's 3 of them. Now, I have a fraction times a non-fraction. How do I turn a non-fraction into a fraction? Over 1. To turn anything into a fraction, you just put it over 1. And now I have 2 fractions. Okay? With fractions, you multiply straight across, right? Numerator times numerator, denominator times denominator. So I'm going to multiply straight across. Because I am multiplying straight across, I'm now going to end up using the product rule. Do we see that? Because I have a times a to the 6, which means I'm doing what to their powers? I'm adding them. So multiply, we get a to the 14 times b to the 3rd all over b to the 6. All right, what's my next one? My next rule. Division. The division rule. I have 3 and 6. Remember when you're using the division rule, your difference goes where the largest exponent was. Does that make sense? Where's my largest exponent? 6 is in the denominator, right? So because 6 is in the denominator, the difference between 6 and 3 is going to go in the denominator. Make sense? All right. If you forget that, then we'll use it as a negative. And the negative tells me that I belong in the denominator. So if I forget that, either way, the negative is my safeguard, right? All right. So we end up with a to the 14th. What is 6 minus 3? So b to the 3. And there we are. The rules may seem like a lot, but the more you use them, the more naturally it'll come for you to just, oh, I'm going to subtract these. Oh, I'm going to add these. Oh, I need to multiply this. But you do have to practice it. Make sense? All right. Was it terrible? No? Remember, left to right, top to bottom. Left to right, top to bottom. All right? Okay, I'm going to pause and I would like for you guys to work these two problems and then check with your group. Okay, so you're going to work these two, check, and then we're going to come back together. Mhm. Don't overthink them. Why are they always in the hallway? It's the same group of boys that walk by like 4 times a day. When I was in school, if you weren't going to go to class, guess what you didn't do? You didn't come to school. Like, you just didn't come. We did not come to school to walk the halls. That just didn't make sense. Like, the amount of people that are in y'all's halls never happened. And I went to a school with 4,000 people. And there are more people in y'all's halls than there are ever when I was in school. It's ridiculous. Be normal. Stay home if you don't want to be in class. The maze, the assignment. Did you get the maze paper? Hmm? You got the half sheet after this. You're working on the maze after this. The rule sheet. Do you have the rules? The paper with all the rules on it? That's what you're missing. Is this an extra one? There's one right here. Here. You didn't get that one then. Is that what you're missing? Yeah. For the maze? Yes. You do. Because a lot of times you guys try to do things in your head and you mess up and you're like, I don't know where I messed up at. So we're going to learn how to, it's okay to show your work. No one requires you to be a mastermind of math. No, you're going to turn in. It says it on there. It's okay. All right, here we go. Let's see how we did. Who would like to start us off? What rule did you follow? What rule? Product. Our bases are the same and we are multiplying. So product means I'm going to have one base and I'm going to combine the powers by adding, which leaves me with 5 to the negative 1. What was the next rule you use? Hence is part of what this is. The negative. You should have used your negative rule. If I have a negative power, that means this actually belongs where? In the denominator. So your final answer should have been 1/5. These are the practice problems. The little booklet we were working on. All right, here. What property rule did you use? Power of product. So we distribute, which means we're multiplying. So negative 3 times 2 is 2 to the negative 6. 2 to the negative 6 means that it belongs in the denominator. Why'd you do that? So your final answer should have been 1 over 64. Okay, if you made a mistake, tell me why. Did you forget to apply the negative? You have no mistakes. Okay. I respect that. I respect that. All right, let's try 11. Are you ready for 11? Ready, set, go. Here we go. All right. Remember, we work problems left to right, top to bottom. So we're going to start at the top. What are we doing at the top? What rule? Product rule. I'm going to use the product rule. The product rule tells me I'm going to do what with these powers? Add them. So in the top, we now have 8 to the negative 8 over 8 to the negative 9. Oh, negative 9. Okay. How do I make these positive? What does the negative tell me? It means that they're unhappy with where they are, right? So using the negative rule, I'm going to switch their locations to make them happy. So this becomes 8 to the 9 over 8 to the 1. 8. You saw nothing. So we went from product to negative, and now what's our last one? Division. If I'm dividing, what am I doing with their powers? I need to subtract their powers. So we have 9 minus 8, and what is 9 minus 8? So the answer is just 8. All right, so on your paper, on your notes, you should have a blank side. Do you have a blank side? All right, I'm going to give you a super problem. You're going to write out that problem. And if you can do this problem, then you're golden. Which one do I want to give you? Yes. All right, write this guy out. You can do this. You can do anything. You should have a blank slide next to what we just finished the notes. Because I had more examples in between. Just for fun, XYZ, some extra rules. If you can do this, you can do them all. I believe in you. Probably and All right, let's talk about it. So, remember I told you we're going to start left to right, top to bottom, correct? Starting with the left, I had this fraction here. In the numerator and denominator, I had x's and y's. So I'm going to simplify those first using the division rule. Does that make sense? So we had -2 minus -3, which is 1. We had 3 minus 2, which is also 1. And we still had z to the -1. Got it? So now my left is done. Now I'm going to go to the right. On the right, we had power of quotient. Power of quotient means that I have to distribute this power to every factor in the numerator and to every factor in the denominator. Power of quotient means I am multiplying. So this became -2 times 2, which is -4. -2 times -1. A negative times a negative is a positive. This became -2 times +1, which made it a -2. And this became -2 times 3, which made it -6. Yes? So now I'm down here at the division rule. I have a z in the numerator, a z in the denominator. Division rule tells me I'm subtracting. So you have -2 minus -6, which is going to be a +4. Now I have everything all out, which now leads me to product because all of these are factors. All are things that are being multiplied. I have x to the 1 times x to the -4, which means I add the powers. 1 plus -4 gave me -3. I have y to the 1 times y to the 2. 1 plus 2 is y to the 3. I have z to the -1 times z to the 4. -1 plus 4 is +3. The last thing is to make sure that all powers are positive. X to the -3 is not happy up top, so I need to move it to the bottom to make it a positive. So your final answer should have been y to the 3rd times z to the 3rd divided by x to the 3rd. More than likely, you intimidated yourself by thinking that, oh, this is too large or this is too big. But as you can see, if you just take it piece by piece, you can do it. Highlighting helps some people. Highlighting common like variables, like bases may help and help you see where you're combining and where things need to be combined. But it is doable. Because as you can see, all we're technically doing is adding, subtracting, and multiplying, right? It's literally all we're doing. All right. Questions, comments, concerns? No. All right. I am going to let you start your maze. Okay. So you're gonna be doing your maze. For your maze, you do need a piece of notebook paper because you do need to be showing your work. So you're gonna number the problem, show your work. On the maze, as you're going through, everyone starts here. And you're going to choose off the paths that make sense for the problem. Does that make sense? So if your answer is not one of the path options, what does that tell you? You did something wrong. Okay. That's not what it means, Miles. It means you did something wrong and you need to fix it. You will be turning in your work page in order to receive full credit. If you just turn in this, you're only getting a 60. If you just turn in a maze, you're only getting a 60. All right. Okay, so we voted to work on this to the end of the period, and then tomorrow to pick up the notes. Is that what we're gonna do?